A formation 40 kilometers wide sits in the Mauritanian desert, visible from orbit as a near-perfect bullseye of concentric rings. No one who first saw it from space could explain why it was so symmetrical. Astronauts flying Gemini missions in the 1960s used it as a landmark, and for years the working assumption was simple. This had to be an impact crater. 2 more decades of fieldwork later, that explanation collapsed, and the one that replaced it still leaves geologists arguing. Over the next several minutes, we'll walk through how a supposed asteroid strike became a slow-motion geological mystery, and why the desert surrounding it turns out to be hiding something even stranger underground. Here's what we actually know. The structure is called the Richat Structure, though it's better known by its nickname, the Eye of the Sahara, located near the town of Wadain in central Mauritania. From the ground, it's nearly invisible, a subtle rise in flat desert with no obvious rim. From orbit, it reads as a target. Ring after ring of exposed rock, each one a slightly different color and texture, wrapped around a central dome. That contrast between what you see from the ground and what you see from space is exactly why it took the space age to even notice the thing existed. The impact theory made sense at first glance. Craters are circular, and this was about as circular gets. But confirming an impact requires specific physical evidence: shocked quartz, a mineral called coesite, and a layer of shattered rock called breccia, all telltale signs of the pressure and heat a meteorite strike generates. Researchers who sampled the site found none of it. No fragments, no impact glass, no debris field. That should have settled the question. It didn't, because ruling out an impact still left the question of what actually built something this symmetrical wide open. What replaced the impact theory is a domal uplift, later carved open by millions of years of erosion. The idea is that molten rock pushed up from below the surface without ever breaking through to erupt, doming the layers of sedimentary rock above it like a blister. Wind and water then stripped away the softer material over time, leaving the harder, more resistant rock standing in rings, essentially peeling the layers of a very large onion down to its most stubborn parts. It's a coherent story, and it's the one taught in most geology courses today. But here's the detail that doesn't fit as neatly as the textbook version suggests. Domal erosion features exist elsewhere on Earth, and none of them are anywhere near this circular. Natural erosion tends to be messy. Uneven rock hardness, wind direction, water drainage, all pulling a dome apart asymmetrically. The Richat Structure's rings, by contrast, are so close to perfectly concentric that some geologists studying it have questioned whether erosion alone is a sufficient mechanism, or whether an additional process, something structural, something related to how the rock fractured in the first place, is doing more of the work than the standard explanation credits. If a purely natural process can produce something this geometrically clean, it's fair to ask why we don't see more examples like it. That's a question worth sitting with, and one worth arguing about, because the honest answer is that we don't fully know. Rock samples from within the structure only deepen the puzzle. The exposed layers span an enormous range of geological time, with some of the oldest material dated to hundreds of millions of years before the youngest, meaning the dome cuts through a stack of rock that took an immense stretch of Earth's history to accumulate. Mixed into those layers are igneous rocks, rhyolite, gabbro, and carbonatite among them. The kind of rock that forms from molten material, not simple sediment. Their presence is one of the strongest pieces of evidence for the volcanic dome theory. But the age and composition of some of these igneous intrusions still don't line up cleanly with a single, simple pulse of uplift, which is what keeps structural geologists revisiting the site instead of closing the file. That question of what's buried and what it means becomes a lot bigger once you zoom out from the Richat structure to the desert around it. In the early 1980s, NASA flew a shuttle radar imaging instrument, first tested on one of the earliest Space Shuttle missions, over parts of the Sahara, and the results were not what anyone expected. Radar doesn't just capture the surface. Under the right conditions, in extremely dry sand, it can penetrate several meters below ground and bounce back a picture of what's underneath. What came back from the Sahara looked like riverbeds. Not faint traces. Clear, branching, unmistakable drainage channels, sitting under sand in a place classified as one of the driest environments on the planet. If topics like this are the kind of thing that keeps you curious rather than just entertained, this is a good moment to consider following along, because the next layer of this story is where the desert stops looking permanent at all. Researchers, including geologist El-Baz, who had been closely involved with NASA's earlier Apollo-era lunar mapping work, went on to analyze these radar images and helped confirm that the channels were remnants of ancient river systems that once carried real, flowing water across what is now the Sahara. The nickname that stuck for this discovery was radar rivers, a phrase that quietly rewrote a basic assumption millions of people had carried without questioning it, that the Sahara has simply always been sand. The buried river networks weren't an isolated anomaly either. Once researchers started mapping them more broadly, dry channel systems turned up across large stretches of the eastern and central Sahara, some in areas hundreds of kilometers from the nearest visible water source today. This lines up with a well-documented period in the paleoclimate record known as the African Humid Period, a stretch roughly spanning 11,000 to 5,000 years ago when monsoon patterns shifted and much of what is now desert supported lakes, savanna grassland, and seasonal rivers. Rock art discovered in places like the Tassili Plateau, depicting swimming figures, cattle herds, and even hippopotamuses, lines up with this same window, meaning the eternal desert was, in relatively recent human history, green. Here's where the two threads of this story start to overlap in a way that's easy to miss. The Richat Structure sits inside the same broader Saharan basin that these buried river systems once crossed. During wetter phases of the region's climate history, the terrain around the eye of the Sahara would have looked nothing like the flat gravel plain of today. It would have had seasonal water moving through it, shaping drainage patterns whose full extent near the structure itself has not been completely mapped. Whether ancient river channels ever ran directly against the Richat's outer rings, and what that would have meant for the site's exposure and erosion rate, is a detail that hasn't been fully resolved in the published research. It's a specific, open piece of the story rather than a settled one. What the data doesn't explain, then, is a clean answer to either mystery on its own. The desert that today reads as the definition of permanence, flat, dry, timeless, turns out to be a landscape that has flipped between green and arid multiple times within a span the human species has been around to witness some of. And sitting in the middle of that same flickering landscape is a rock formation so geometrically precise that the leading scientific explanation for it, a slowly eroded volcanic dome, still hasn't accounted for why the erosion came out this symmetrical, or fully resolved how much of the shaping came from water that no longer exists there. So here's the honest split. It's proven, beyond real dispute, that the Richat Structure is not an impact crater. The mineral evidence for that verdict is unambiguous. It's also proven, through radar imaging and paleoclimate data, that the Sahara cycled through genuinely wet, river-fed phases well within a time frame that overlaps human settlement of the region. What remains genuinely unresolved is narrower, but real. Why natural doming and erosion produced rings this close to perfect symmetry, and how directly the region's vanished river systems shaped the ground the eye of the Sahara sits on. Researchers have not fully closed either gap, and no invented explanation would make the honest version of this story less interesting. Picture that same formation again. 40 kilometers of concentric rock, visible from a spacecraft window, mistaken for a wound left by an asteroid. It was never that. It's something slower and, in its own way, stranger. A dome that pushed up from underneath a green and river-fed version of the Sahara, then sat still while the water disappeared and the sand closed back in around it, ring by ring, like a landscape holding on to the memory of something it no longer resembles. The rivers are gone. The symmetry is still there. And exactly how those two facts finished shaping each other is a question the rock itself has not answered yet.